Hi there, this is Max Fisher, and I will be presenting to you my science projects and advanced projects in physics. I embarked on two projects, both which involved electromagnets and electromagnetism, but in slightly different ways. One of my projects involves the idea of magnetic suction, while the other involves concepts of torque. I hope you enjoy and find my work interesting. For my first project, I worked with the idea of magnetic suction to replicate the process of an old doorbell. The materials I needed were as much 24-gauge wire you could get your hands on, a plastic drinking straw, a large 6-volt battery, an ordinary steel nail that could fit into the straw, not stainless, this is very important, a wire stripper or sandpaper, scissors, and alligator clips. So, how do old doorbells work? When you hold down a doorbell button, it closes an electrical circuit so that the household current flows through the electromagnet, or electromagnets, by way of a transformer. A transformer is a simple device that takes the 120-volt household current and steps it down to a 10-volt current. This current is then passed through the electromagnet wire. While my project didn't involve transformers, it replicated this process exactly. So, for the physics behind this project. Any moving electric charge creates a magnetic field around it, as we have talked about in class. A loop of wire with a current creates a magnetic field throughout the loop. You can increase the strength of this field by piling up a lot of loops. Hence, when I say you need a lot of wire, I mean that you need a lot of wire. The more loops, the stronger the magnet. Like a bar magnet, this coil of wire now has a north pole and a south pole, and is an electromagnet. When I brought the steel nail near the south pole of my electromagnet, the north poles of the iron atoms attracted to the south pole of the electromagnet, and they line up pointing in the same direction. The nail is now magnetized, with its north poles facing the south pole of the electromagnet. The opposite poles attract each other, so the nail is sucked into the electromagnet. When the direction of current is reversed, the poles of the electromagnet reverse. Knowing this, I had thought that the nail would then be ejected from the straw, which I was really looking forward to. However, I was incorrect, and the reason why the nail won't ever eject from the straw is because all of the nail's iron atoms reorient to line up with whatever pole the electromagnet presents. Thus, the nail will always be attracted to the electromagnet and will never be repelled. To be honest, I was very happy with my first project. I was able to complete it without any noticeable complications, and it demonstrated exactly what I wanted it to. Another cool part of the project was seeing how warm the coil of wire started to become. The electrons that are moving throughout the wire actually will bump into the wire, allowing the layers upon layers of wire to gradually heat up. And now, let's move on to my second project, which is the demonstration of a motor based off of electromagnetism. By using two permanent magnets and an electromagnet, which is created when current is passed through a coil of wire, the hope was to have the coil spin around itself as it constantly interacts with the other magnets. The materials I needed for this project included several feet of copper wire strippers, a Sharpie, a plastic cup, 2 disc or ceramic magnets, 2 large paper clips, masking tape, aluminum foil, and either 1 or 2 C to D size batteries. So for how the project works. The current flows through the battery, aluminum foil, and paper clips, and then finds itself into the wire coil, creating an electromagnet as I have mentioned before. One face of the coil becomes a north pole, and the other a south pole. The permanent magnet, or in this case the 2 small metal magnets I had used, attract its opposite pole on the coil and repels its like pole, causing the coil to spin. The repetition of this process is what allows the engine to continue to run as long as there is a constant current flowing from the battery. Another way to describe the operation of the motor is to say that the permanent magnets exert forces on the electrical currents flowing through the loop of wire. When the loop of wire is in a vertical plane, the forces on the top and bottom wires of the loop will be in opposite directions. These oppositely directed forces produce torque on the loop of wire that makes it turn. One of the directions in the manual was to paint one of the sides of the coil black, and to make sure to clearly delineate this on the coil. Why is this important to the project? Let's say that the permanent magnets are mounted with their north poles facing upward. The north pole of the permanent magnet will repel the north pole of the loop electromagnet and attract the south pole. This will hinder the ability to run the engine. But once the south pole of the loop electromagnet is next to the north pole of the permanent magnet, it will stay there. Any push on the loop will allow the magnet to reach its equilibrium position, and the engine will start running for the considerable future. These ideas of north for south poles were very similar to my first project. By painting half of one end black, you prevent current from flowing for half of each spin, rather than for the entire hole. The magnetic field of the loop electromagnet is turned off for that half spin. As the south pole of the loop electromagnet comes closest to the permanent magnet, the paint turns off the electric current. The inertia of the rotating coil carries it through half a turn past the insulating paint. When the electric current starts to flow again, the torque is in the same direction as it was before. The coil continues to rotate in the same direction. Unfortunately, my project didn't run consistently, most likely for the following reasons. I believe I ran into some complications surrounding the magnets I had been using, as well as the balance of the engine. The project called for ceramic magnets, but since I didn't have those at my disposal, I used stronger, metal-based magnets, and the paper clips that held up the current would continue to be attracted towards the magnets. This would offset the balance I had made, and would cause me to redo the balance aspect of the project. In addition, my coil that I had made was slightly less even than the example coil, so I believe that also caused some error. I hope you enjoyed my final project explanation. I was very happy to see that my doorbell simulation worked very well, but unfortunately my other engine didn't work consistently. I had a lot of fun with these projects, and I hope you could go out and reenact them. Thank you for listening.